All right, so last step, let's get real feedback on our fader. One more line of code, real feedback on our fader. Looks like what?
Controls
dot fader level dot value is going to take on var actual level. var actual level. Hit save and recall a preset and see that it works. Also, while we're here, go back up to all this fake feedback stuff and take that stuff out. Deactivate the fake feedback so that you can see that it is absolutely working by itself. It's not cheating. If I press preset 1, that tells the system to go to fully on, and then we saw that we started getting return from the lighting system, and it was telling us, oh, I'm updating my level, do. And then we saw the fader respond by going, okay, I'm going up too. It moved because there was real feedback being provided. Now, Nate, I know, is going to also want the presets to illuminate properly as well, because we just got rid of that fake feedback. So let's fix it up. How can we illuminate the preset buttons appropriately? Any ideas, Nate?
Okay, so if the number that we just pulled out of this matches any of those 4 things we shoved into our array, then we would want the appropriate button to illuminate as well.
You got it.
Okay.
Yep.
That sounds like 4 different if statements, but I bet you got a slicker way, don't you?
I do.
Yeah.
I do. Let's not use the if statements, because remember, maybe you've got 5, maybe you've got 10.
Exactly.
You can have a variable number of buttons, and you don't want to have variable length code. You really would love for just to have one set of code that just works for however many presets you choose. The way that I have in mind to solve this problem is going to lead us back into the land of arrays, to think about arrays. So let's come back up here to our array of levels. So remember, when we are talking about arrays, one of the things that we are talking about is that we are talking about the fact that we are associating keys with values, right? Keys with values. Or more specifically, we are creating something like this. We are creating the fact that our levels, bracket 1, equals 99. We are creating the map of 1 to 99. Wouldn't it be really great if we had a map that took us from 99 back to 1? Have you seen this idea before, Nate? Maybe a little fish in your ear?
Talking about you want to build a reverse table?
I want to build a reverse table here that will take my preset levels, but will also build a reverse table so that I can then just look up the answer. Because I don't want to do what Nate suggested, which is to build a big else if tree. The middle answer that Nate didn't suggest was we could write a loop that could do comparisons, and when they matched, then turn them on, which would work. It would work, but that involves calling loops inside of loops, and I don't like to do that if I can avoid it. I would rather be clever and just do a lookup. So let's build a reverse table. We build a table like this, and we will call it TBL for table, and we will call it, he said reverse, so we'll use reverse. That's fine. TBL reverse levels to buttons, just to be extra verbose so that you can see what we're talking about. And I mean, seriously, it's only 4 entries. We could seriously just type it in and be done with it, but I'd rather plant one more neat idea. Here's a neat idea. Let's write a for loop that will automatically populate the reverse table. We won't have to write it for ourselves. We'll make the loop write it for us. And I'm going to do it. It's going to be a little bit different than what we've done before, but this is okay. Right? 4, and notice how VS Code will give us an opportunity to use autocomplete. Use autocomplete in this instance. So there we are. 4 key comma value in pairs on a table do the following. In this particular instance, I'm going to keep key and value as our variables because we have key 1 associated with the value 99. We definitely want to reverso those around. What table are we working on? We are working on R levels. And so what do we want to put into table reverse buttons? We want the keys of table reverse level to buttons to be the value of R levels, and we want the values of our table reverso to be the keys from R levels. And the thing that I think is most delightful is if I ever go and decide to change however many entries are in R levels, the next time the code runs, this for loop writes the reverse table for me. I don't need to think about it. All right, hit save. And you ready? We already know of a way to make the lights illuminate, don't we? Our preset lights to illuminate. We have a function for that, don't we? Do you remember?
Func interlock?
Func interlock. What does func interlock run on? A number.
Yeah.
The number we want to turn on. So func interlock is looking for a number. In fact, it's the number of the button that we want to illuminate. What is the number of the button that we want to illuminate? This is the magical thing about working with the tables. The argument is that table reverse levels to buttons. And what is the thing we want to look up in the table? The actual level. Because what did we do? In R levels, we corresponded 1 to 99. In the reverse table, we corresponded 99 back to 1. Hit save. Hit go. Notice what happens. Now, as you hit all of those appropriate matches, your preset buttons will illuminate at the correct things. And we didn't have to write any loops in our code, right? We have the one loop that runs at the beginning of the script that will write the reverse table. And then when we run func parse level, we take the actual level, we look to see, is that in the table? If it's in the table, then it tells us which lights to turn on. If it's not in the table, then it tells us nil, which we've already seen in our case, right? Because nils are usually radioactive, but it's okay here because we've already used it in func interlock to see that that just turns off all of the preset button. And with that, we're going to take a little break, and we'll see you in the next episode.